Thank you. Well, many people here know me, and many people know that I sort of play with DNS, sometimes even at NetNode. There are many interesting things happening in the DNS space. Well, that's always true, and some of us, we thought that DNS is sort of just a passing fad that we will play with for a few years, and then we will move on to more interesting things. But, well, guess what? DNS is something you can actually play with for your entire professional life. One of the things that are happening now is that things are getting more difficult. And if we very, very broadly divide DNS into two parts, the authoritative part where we publish stuff and the recursive part where we look stuff up, guess what? The problems are mostly in the recursive part. For many, many years, we I will not say ignored, but at least we didn't solve the problems in the recursive side. We had DNS spoofing, we had all sorts of bad things happening, but we, well, didn't really solve the problems. But the problems are getting worse, and it's time to do something. So we have a DNS system, we have a DNS infrastructure that we are all very, very much dependent on for everything in society, essentially. Of course, it's used enormously for all sorts of official services, all sorts of legal activities, everything that we do all the time, but it's also used for other things. We do see illegal activities. We do see things like botnet control that has usually some sort of call home for instructions infrastructure that is often DNS-based. We do see DNS components in other types of bad activities of the network, be it phishing or whatever. On top of that, we have all sorts of, let's call it, tracking activities by big providers of different kinds that would very much like to see what you are doing right now and what your dog is doing and exactly what YouTube videos that the dog are watching. This is not illegal as such, but it's not necessarily in line with what you as an end user wants to see or wants to happen. Most of us do have some sort of sense of what is private and what is not private, what is only for me and my family and what is for everyone to know. So these other uses of DNS are unfortunately growing. The traditional uses of DNS, they are growing too, but these other things are growing faster. So over time, this problem is sort of getting worse. Enter what is called threat intelligence. This is a booming business. There are all sorts of companies that are selling threat intelligence data. It could be some sort of API that you connect to and it tells you what is good, what is bad. It could be some other format. Traditionally, it was lists of domain names that you imported, and these domain names are bad. If you see one of those, don't look it up, etc. The question to ask is, okay, you claim that this is bad. Based on what information? What is the provenance of the information that makes you say that this is bad? Is your definition of requirements for bad aligned with my definition of what is bad? And the reason why these questions are so important is that we all really want to avoid so-called false positives. I mean, for instance, for an internet service provider, blocking stuff that should not be blocked will immediately cause users to be upset. And upset users are not what you want when you run a small margin business. So the provenance of the information is really important here. So what are the sources? Well, in essence, if you are a security company and you are in the business of providing threat intelligence, you will use any data. Every piece of information is of value to you, and you try to put this mosaic of information together. And in the end, it turns out that one very interesting component in this mosaic would be recursive DNS traffic. what exact DNS queries are being asked by whom exactly when. That is very, very precise information, precise both in what and in time and in who. So the DNS traffic would be great. However, great as it is also, how should I put it, not by itself enough. DNS information is a component in this mosaic. It's an interesting component that would increase the resolution, increase the precision in this complete picture of threats and things that are happening that you may want to avoid. But it's a component, not a solution by itself usually. However, it's also very sensitive. It's integrity sensitive. It exposes a lot of what people do on the network, what they care about on the network, what their contacts are, etc., etc. And for that reason, most DNS operators, as in recursive service operators, they say no to the security companies asking for this information because they want to protect the user's integrity. And that's of course good, and we appreciate that. But it's also a loss to some extent because the information would be very valuable if we could somehow get to the information in an integrity protecting way. So the question now is there a solution to this problem? Well, we're trying to find one, and I think we've come quite far. So the DNS Tapir project is primarily sponsored by PTS. There's additional funding from NetNode, from Internetstiftelsen, where I work, and SUNET, where we add more resources and people time, etc., to play with this. And the goal is to establish a collaboration between operators of recursive services and us. However, we cannot reach this collaboration, we cannot reach this, this system in Sweden of everyone contributing unless they actually trust us. We need to bridge this gap that has been for probably more than 20 years of no, operators do not trust DNS analysis services to be sufficiently careful about the integrity of the user information so that they share information. We need to bridge that gap. And how should we do that? Well, obviously we need to get their trust. And the way to gain trust is through transparency. And in our case, the way to achieve transparency is through open source. So what we are designing is a system which is completely open source. It has this collection ability that everyone has for DNS traffic information. We anonymize it close to the resolver, so the sensitive information never leaves the premises of the DNS recursive server operator. We only see aggregates and events and things. We never see who or what or anything like that. And because it's open source, anyone can just inspect the code or have a security analyst inspect the code and say, this is actually correct. The DNS Tapir system does not sell your information onwards because it doesn't leave your box. You can just do a git clone and compile it yourself if you don't trust the Docker image or whatever you get from us. So we have an architecture. It looks fairly complicated. I will not go through all of it. But the interesting part here is that you have at the bottom a rectangle, what we call Tapir Edge. That is the existing resolver that is run by a resolver operator, plus a couple of more components that we add. And then you have a core, which is typically run in some cloud somewhere where we do the central analysis. In the edge, we get the traffic information from the resolver through DNS tap to something called EDM, Edge DNS Tap Minimizer, which removes all the sensitive information, sends events and aggregates of information over to the core for central analysis. It's very important that we get this from as many operators as possible, because for this to work, we need a baseline. And the baseline needs to be constructed out of a sufficiently wide collection of information to be relevant. If you just get something from my house, which is my wife, me, and my dog, that will not be enough to establish a stable baseline of what good traffic should be. So analysis happens in the core, and then we send it back to something called the policy processor. And what we send back is not blocking instructions. What we send back is observations. We're saying, this domain name exhibits the following properties. For instance, this domain name is new. It hasn't been seen on the internet until a couple of minutes ago. That's usually a bad sign, but it doesn't have to be a bad sign. Or we can say, this domain name exhibits a rapidly up-ramping amount of traffic. That doesn't have to be bad. It's usually bad, but just doesn't have to be bad. But it could also be that it exhibits both being a new name and rapidly up-ramping traffic. And those two indications together is a stronger indication of this being bad. So what we say is, this domain name exhibits the following properties. You make the decision. We are only telling you what we get from our analysis, not what you should do. So this policy processor is somewhat complex. It gets the observations from the Tapir core, it gets other kinds of threat intelligence through other formats. It has local allow and deny lists for stuff that should never ever be blocked or must be blocked, etc. And in the end, it minimizes all this, sends it over to the resolver as a list of instructions. Over to the right there, you have something called local policy config. And this is really the core part of where the change is. Previously, you got into the resolver essentially a feed which said, block this, don't block that, etc., etc., etc. There was no judging of information. We add this policy configuration which says, you shouldn't block something just because it's in the RPZ feed from this commercial service, or you shouldn't block something because of that. You should value the information and say, for instance, it could be that I need to have something flagged by more than one source. If a domain name is claimed to be bad by both a set of Tapir observations and also flagged in this commercial service, oh, I have a second opinion. Good, then I will block. I will not block on just one opinion. I need multiple. Or it could be, I have all these Tapir observations together is a sufficiently strong indicator for me to make a blocking decision. The important part here is that everyone will have their own definition of what is the right policy. My guess is that an internet operator, they will have a rather relaxed policy because they really don't want false positives for their users because that could cause the user to change to a different provider. On the other hand, if this is a government agency, perhaps they should have a somewhat stricter policy. So it's not one size fits all. It really depends on the use case and the user base. We are at the end of phase 1 of this project. We have a working prototype. The entire loop is complete. All the pieces work. We have a public resolver that people play with, both inside the project and outside the project. We are mostly done with all the components. They will be polished further. They need more development and all that, but it's up and running. We want to go to the next phase. The next phase being going from a prototype to, let's call it productizing Tapir, making this essentially a society effort where resolver operators work with us by providing data. We analyze the data, we provide a feedback with our observations. It's possible to provide data without using the observations, that's fine. It's also possible not to provide data, but still use the observations. That's fine too. You can combine it in any way you want with your other sources of information. That's absolutely fine with us. And this policy engine is designed just to help you with this merging together different types of information sources to give you control over the complete result. My view, as a DNS purist, I said for many, many years that what the authoritative server publishes is what the end user should get. And it's not the place of the recursive server to apply local policy. It should just be a conduit between the authoritative information and the consumer of the information. That was a good idea at the time. I do no longer believe that this is a working policy or a working model. There is so much bad stuff in the DNS infrastructure that we simply have to do something. And we want to make sure that whatever we do, we must protect the user integrity. So we must find a solution that protects the user integrity. We must find a solution where this design of the policy is a local matter rather than a one-size-fits-all. This is what you should block. Big Brother sees everything, and Big Brother makes the decision that these things should be blocked, and then you're fine. Because needs are different. This is our proposal for a solution. It will work fine if we all collaborate, and that's what we're hoping for. If we just sit off in our corner and wait for data and nothing happens, this will fail. But I really think that from a society perspective, in these days, we need a solution to this problem, and this is our proposal. Thank you.
We have time for a quick question for Johan. I think we have one of a mentee. Yeah.
So someone is asking if it's possible to take part of this information without sharing something by themselves?
Yes.
Thank you.
Okay. Okay, simple answer. Please join me in thanking Johan for his presentation.
Thank you.